Our focus today of the Recovery 2.0 system will be on the treatment and processing of mixed solid wastes and how the system is designed to align with today's environmental sustainability practices in the approach and treatment of residual end-of-life materials. Recovery 2.0 provides an opportunity to learn how to manage resources in a sustainable method by treating waste as a resource, while assisting with the world's demand for clean water and clean energy, using thermal reduction. The typical historic thermal reduction method of waste recovery utilizes various forms of combustion. The shortfall of these systems has been the undermanagement of emissions and the lack of accounting of the total waste in comparison to the total product outputs. Traditional energy from waste systems tend to focus mostly on the solid ash content and limiting toxic emission levels, but the balance of the largely unaccounted for materials are released into the open atmosphere. The Recovery 2.0 thermal reduction process converts mixed waste streams on a mass balance basis where a ton of waste feedstock or input will account fully for a ton of output products produced. The process has two intermediate pathways consisting of solid and gaseous phase fractions. The thermal reduction of pre-prepared municipal solid waste in the form of solid recovered fuel consists primarily of mixed hydrocarbon materials. These are common materials such as organic and food waste, wood, paper, rubber, plastics, and all forms of textiles and oils. These materials contain various moisture contents. The thermal reduction process converts the mixed wastes into a solid residue fraction and a hot gas fraction. The solid residual fraction generated from the solid recovered fuel thermal reduction process may only account for less than 5% of the total output depending on the consistency of the source feedstock. The hot gaseous fraction generated from the solid recovered fuel thermal reduction process, sourced from typical municipal solid waste, may range from 75% to 95% of the output. The hot gas is a rich feedstock that is refined into basic elements. The bulk of these gases are hydrocarbon-based elements and complexes with a small content of non-hydrocarbon materials. The hydrocarbon fraction is split into clean hydrogen and solid carbon. The recovered hydrogen product may be sold externally or consumed internally as a primary fuel to drive the Recovery 2.0 thermal reduction process. The typical moisture content of solid recovered fuel may range from 15 to 30% of the weight, and food waste can contain greater than 50% water. The water content is converted into and included in the gaseous fraction. The gas fraction typically expands from 100 to 2,000 times the volume from the original waste feedstock. Solid wastes, referred to as dry wastes, contain a natural water content. Therefore, the total yield of water recovered from the processing of mixed solid wastes is the combination of the water from the solid wastes combined with the water recovered from the wet organic materials. The challenge in the gas phase processing is managing the sheer volume of gas generated with the range of temperatures and pressures. Special precautions are required for the handling of those fractions that are toxic or are flammable in nature. Combustion-free options are available. By utilizing a combination of novel and passive approaches to resource recovery, that are traditionally deemed as less efficient or not energy dense, it may be possible to achieve neutral emission goals with short-cycle regeneration methods. Short-cycle regeneration is an approach that uses minimal storage reserves, but rather relies on rapid-cycle recharging from compatible symbiotic modules, from within the overall process, to produce electricity on demand. Typical hydrocarbon waste materials generated from municipal solid waste, in the form of solid recovered fuel, contain complex hydrocarbon molecules or long-chain polymers. The gas phase of the solid recovered fuel thermal reduction process produces a mix of carbon, hydrogen, and oxygen, typically made up of approximately 95% of the volume, with the remainder of all other gases and vapors combined totaling less than 5%. The thermal reduction process breaks these molecules, or long-chain polymers, into shorter chains or monomers. Adding additional heat, dwell time, or pressure to the thermal reduction process will promote a further, or more complete breakdown into simple elements. For example, mixed hydrocarbon may be reduced to produce elemental carbon and hydrogen. Typically, depending on the blend of raw input, The content in a common solid recovered fuel feedstock will yield carbon as the most abundant component of the solid fraction. The raw solid fraction, consisting of a mix of raw recovered carbons and residual materials, also commonly referred to as biosolids, biochar or carbon black, need to be further processed in order to recover a purified carbon product. After the removal of the purified carbon, the remaining solid fraction residuals consist of a mix of mineral content materials, directly recoverable metals, and a mix of strategic or critical trace residue elements. Some of these materials may require high-temperature refining or other specialty treatment to facilitate selective recovery. Emissions generated from the thermal reduction unit are vented and contained within a hydrocarbon working fluid pipeline. The pipeline feeds the hot gas refining process where the product-charged working fluids are segregated and converted into the desired output products. If the chosen primary energy source produces hydrocarbon emissions, those emissions may be merged directly into the product stream pipeline and fed into the hot gas refining process. Unlike traditional incineration, or energy from waste approaches, the Recovery 2.0 process captures what would be flue gas and cooling tower emissions and converts them directly into product outputs. This process extracts value from the recovered resources while eliminating the undesirable emissions. In summary, the Recovery 2.0 thermal reduction processing of solid mixed waste materials utilizes a sustainable approach to treat waste as a resource, with the goal of recovering valuable materials, while generating no undesirable emissions, and potentially harvesting enough energy to offset the energy costs required to operate the system in an attempt to achieve a net zero energy processing cost. While the resource recovery of mixed solid wastes must deal with the management of all the complex elements contained, the main focus of the Recovery 2.0 efforts revolve around the three predominant elements of carbon, hydrogen, oxygen, and the energy required in their transition. Recovery 2.0 was developed by Waste.net as a system to manage resources in a sustainable method by treating waste as a resource. If you would like more information about the Recovery 2.0 process, additional videos are available and links have been provided in the comments, or feel free to reach out to us. Waste.net is a tool to assist you by matching waste material generators directly with beneficial users of those materials. By connecting you with market participants, we foster collaboration and promote environmental sustainability. Visit our website waste.net today to learn more. Let us assist you in your efforts to manage your waste. Waste.net may also be able to assist you in finding a market to buy or sell your scrap waste or byproducts.